There we go. Thank you for stopping me. All right. Fast forward. Welcome to Cluster API, Wednesday, 18th of December. I already said the preamble, so I'm not going to say it again. This is the part of the meeting where we usually welcome new folks. If you're here for the first time or haven't been here in a while and you want to identify yourself and say howdy, please do so. I'll be quiet for a few seconds and let you do that. I think we just have familiar faces. It's great. Um, okay, next up, we go to open proposal readouts. Um, we have the in-place updates proposal, which I know is coming up on the agenda. So I don't know if we have anything to say right here about it, but please interrupt me if you do. Do we have any updates on the node provisioning working group? Are we meeting this week?
Yeah, we do. And the PR should be ready for merge. There was like one minor thing with a test that was unable to read a certain link, a URL, and I got a patch for that like briefly after last week's meeting, and so that should work now. I have no idea how to kick off tests again. So pardon my ignorance. It should go through this time, but someone probably needs to kick the CI.
Okay. On this PR or on the
No, that's the in-place updates.
right. Oh, sorry. Okay.
The proposal one. If you look at, that's the one. Yeah.
I'm afraid to jump too many tabs here because I'm staring my screen. All right. We just need to restart CI on
I think, yeah, that should do it. It didn't run after the last merge got in, so
okay.
it's one single test that for some reason failed on a very valid link, but someone obviously understands the CI better than I and fixed it, and I merged it, so we should be good.
Great. All right. Well, I'm not a maintainer, so I will leave that as a task for someone who is to kick it. Cool.
And yeah,
Anything? Yeah.
otherwise, we have our last meeting this year tomorrow. I'm not sure if you already have any progress. Johanan is nodding, so awesome. There will be stuff to discuss tomorrow, and then we'll be off for the festive days and meet again in January.
Awesome. It's great to see the progress. All right. So after that, here we go. Moving on to discussion topics, we have the in-place updates proposal. Guillermo and or Alex, go for it.
Yeah, I think we discussed this last week. So um, we added a bunch of examples to the proposal and wanted to take the opportunity to walk live through them instead of asking folks to review this offline to see if we can uh, speed up those questions and that feedback loop. So if you could open the render markdown version, I can post a link. But if not,
Um,
yeah, yeah, exactly. So if you could,
Kind of
once it
slow.
loads,
There we go.
if you could scroll down to the examples section.
Is the link gonna work? Oop.
It didn't work in my browser, but maybe it
Okay.
worked here.
Oh, oh no, it really didn't work. Bye bye CSS. Sorry, I'll just scroll down by hand. Uh, oh, okay, here we go.
Okay. I'll give a 1 minute summary of what this proposal is about and the general approach to solve it. Inputs upgrades is the updates, is the ability to updates update machines without replacing them. So far in Cluster API, machines have been considered immutable. So every time that you need to make a change that requires changing something in the machine at the infrastructure level, then you need to replace it. This proposal, it's about introducing a new mechanism that adds the option to do those things in place. The idea is that we could have external updaters. This is a new concept that is introduced here. And we can still have Cluster API detecting when those changes are required and then orchestrating those updaters that could have different responsibilities in order to achieve the desired state. That is an oversimplification, but hopefully it can it helps for folks without previous experience with this proposal. So what in this example we're going to go about is imagine a cluster in which you have two external updaters. One of them is for vSphere VMs and it's able to update the memory of those VMs in place. That's its only responsibility, and that's the only type of change that it can perform in place. And we have another one for Kubernetes version upgrades for KCP. That's the only type of change that it can perform. In this case, we are assuming that we're running some kind of agent. So bear with me here. This is an example. We don't have that today, but there's some kind of agent running in those control plane machines. And then we have a way to communicate with this agent. And the agent takes care of running KubeVM upgrade whenever we request a Kubernetes version upgrade. Okay, so if you scroll down, we can start with the first scenario. By the way, anyone who has questions, feel free to stop me at any point in time. The first scenario is upgrading the Kubernetes version of the control plane. This is a simplified example. Anyone with experience with Cluster API will tell me that you also need to update in this case, if it's vSphere, you'll need to update the VM template in the infra provider template when you update the Kubernetes version, but just bear with me. So we're updating from, sorry, did someone say anything or?
What's that?
Okay. No, never mind.
Okay.
So upgrading from 130 to 131. The user UX here is the same as any other update or rolling replace updates as today, right? You update the version in the KCP. Except here, these KCP have been defined with the rollout strategy of type in place. This is the new, that's a new value for this field. The first thing that the KCP does is, as today, runs a comparison between what it has or the desired state and current state, detects that there is a change required there. And the first thing that it does is it starts contacting those external updaters that have been registered through, in this case, an extension hook, but it's just an HTTP request. And it says, I have this machine, and this is the desired state for the machine, the bootstrap config, and the infra machine. And these are the fields that I have detected where changes are required. And it contacts each of the updaters, and the updaters respond with an array of the fields that it can update. So if you go to if you scroll a little bit up to the diagram, yeah, here you can see where we have the two updaters, the KCP version update and the vSphere memory update extension. It first makes a request to the vSphere memory update extension, and this extension says, I cannot update anything because the two fields that need to be updated, none of them can be handled by this extension. But then when it contacts the second extension that has registered the KCP version update, this extension responds that it can update all the required fields. If there were more fields then that weren't covered by this extension, it will try to keep contacting other extensions. In this case, there are no more extensions, but with the second one, we cover all the changes. Now you can scroll down if you want, and we can see that response. Yeah. So here we see where it makes the exact same request to the KCP upgrade extension, but in this case, it responds, hey, I can update the spec version of the machine and the spec cluster configuration Kubernetes version of the Bootstrap object. What now the KCP controller does is update the machine with the new version, which is the change that it required to do, required to make. And then it updates the reference of the, in this case, the kubeadm config to a new kubeadm config that has the new provided configuration. Then the, and this is a new field that we will be adding to the machine, the updaters field. So in this case, there's only one, but imagine that we require more than one updater in sequence to achieve all the desired changes, then this will be an array with all of them. In this case, there's only one because that one can cover all the changes. It makes those changes to the machine object. Then the machine controller sees these changes. And since it sees that there is an updater that needs to be executed, it adds a condition, or it changes the status of the condition to not up to date. What it now would do is execute those updaters, in this case, again, there's only one, in order. And how those updaters are executed, each updater needs to implement another endpoint. So the first one was, hey, can you handle these changes or not? The second one is, go execute the changes. In this case, the only input is what is the name of the machine and the namespace, because the machine spec has already been updated. So there is no need to say these are the changes required. You just pass the machine and that's the desired state. It will keep pinging this, or in this case, the extension will send those orders after accepting this change. Will send those orders to the agent. The agent will execute kubeadm upgrade. It will do the process with node, and then the process will be reported back to this webhook. Eventually, the machine controller during this process is going to keep hitting this endpoint saying, hey, update this, update this. The extension is going to say that is in progress. This try again is just a way for the upgrader or for the extension to request, hey, ping me in this amount of time. So for shorter or longer operations, the extension can require longer or shorter polling. And eventually it gets completed. So the status is done. So you can scroll down a little bit more. This means that the machine is now up to date. So the machine controller updates the condition and removes the updater from the array because it has already been executed. Now the next KCP reconciliation, the KCP controller will see that these changes have already been updated, so that machine matches the desired state, and it will detect that the second machine of the control plane require also changes. It will do the exact same process, same thing for the third one, and eventually all machines will be in the desired state. Any questions so far? Yeah, Beans.
Yeah, thanks for walking this through. It was a good refresher for me specifically. But I think I might have added a comment in the rules a long time ago about this. The general feeling I had, right? This could be wrong, but is that because of the synchronous model and the whole tracking of like what has run and what has not run, it almost feels like we're kind of trying to like recreate like what controllers should do in the first place. So, like just declare the desired state and understanding where things are at, but in a different way. So like I'm really curious like on why we picked synchronous calls and keeping state around versus understanding like before things get registered, like what can be done in place, and expect the other controllers to push that update in place, and then have normal timeouts and whatnot.
That's a good question. The main reason we introduced this sync communication was to have the ability for the extensions to communicate what were the changes that could be that they could handle. And I'm not saying there's no way to handle this with an asynchronous model with controllers and having other fields, but that was the reason we introduced it. There are two reasons why we wanted this ability. One was to make sure that an updater didn't need to implement all possible changes for a particular resource. So, you could go to vSphere and say, imagine that we're only handling VM updates, right? It's like, well, there are many, many fields in the vSphere machine that you could want to update. But in this case, I only want to implement updates to memory because that's all I want to cover right now. So having the ability for the updater to dynamically say, hey, I can handle this or I cannot handle it, was useful in our opinion. And the other one was to be able to have, this is kind of like an addition that we added later, to have multiple updaters that could be running sequence, each of them taking care of a particular subset of the desired changes.
Yeah, I think those seem like very valid use cases. I guess they're though very, very similar to like registering an admission or a validation webhook. As in, I can do things on these objects and I know how to do them, and just call me when I need it from the API perspective, right? So if we have that information somewhere and that is registered ahead of time, not at runtime, because if things can change at runtime, well, you can get into a weird state. But if these mutators or in-place mutators are registered ahead of time, and you know which fields can be mutated at that point, right? So you can make a planning memory of some sort, and you know the diff between the old and new because you need to do something similar in the machine deployment at this point. Then the controller could just sit there waiting for those updated without like it doing any extra calls and without introducing like a state machine within the machine deployment controller, which is going to be my main pushback here. It's like we're recreating a state machine, which kind of goes against like just general Kubernetes practices.
Yeah. So yeah, there are two things there. The first one, yes, you're right. If the capabilities of an extension can be defined in a static way, then there's no need to make this request dynamically. I think the idea was here that we didn't want to limit to a static definition of capabilities. And this is going into the what if, right? So I'll take that as a valid critique to this design. But there could be changes that are not as easy to define as I can update this field, regardless of what is the update, right? There can be fields that can be updated only if other fields are not being updated. There can be fields that can be updated depending on the value. And the only way to do that it's not the only way. But the way that we decided to approach the problem in that way was just to do it dynamically. Now, that's not to say that that doesn't have drawbacks, right? So I'll definitely see what you're saying. On the recreating the state machine, I understand your concern. And I'm happy to hear alternatives to that if they simplify the design. And maybe we need to take a step back and discuss first those requirements that we set ourselves, because maybe if we don't agree on those, we'll never reach an agreement on the solution itself.
Okay. Yeah, I guess like my main feedback here is like, do we need all of those things immediately, right? So can we start like something very, very simple to that then we can prove it works before we add like, and to be clear, this is just like the conversation that we have over the years, right? It's like when we add a very large features, it's like, okay, let's try to build the ocean physics where we want to arrive, but then it's like, okay, can we actually build something very, very simple first, or like to see like if it actually works? And so that's where was coming from, is there is a lot of moving parts in the proposal, which I do appreciate that like there are a lot of requirements as well. Because then when you said it's like there can be condition, first thing I thought, I was like, well, isn't that just a cell rule that like it could just be applied at that point, right? It's like on the incoming object. But then it's more complicated that way. So I almost didn't want to say it out loud. So I hear you. I would maybe we start thinking like about, do we need all of the things that we do have listed in here for the first iterations, right? Like, can we make decisions that are not one-way doors today and start experimenting and gather feedback before we move on to the more complex features that we want to offer? Because from
That's
a
totally.
container, I guess other maintainers are not here. Like, but from a maintainer perspective, we have seen like like a lot of like large features. There's like they could take months or years like to just get it implemented and tested and validated. Something simple takes way less at the end of the day.
That's fair. That's totally fair.
Any other
Um,
comments? Do we want to keep going on the doc changes?
uh, so I think I already took like 20 minutes, or almost 20 minutes. I said that I wasn't going to take more than this. Are folks interested on going over the rest of the examples? If not, maybe we can just leave the rest of the examples for next week. The general idea is the same, right? Like the second example just goes over updating the memory. So instead of doing what the KCP upgrade does, it just goes through another updater that calls the vSphere API. So yeah, I don't want to do the whole time here.
Okay, up to you. I don't think we have anything else on the agenda. All right. Any other questions or feedback about in-place updates? That's the clapping thing, right, Tilo? I can't really tell. Yeah, okay. We don't have anything else on the agenda, but does anybody have anything else on their mind that we should bring up? The oh, not to be too much of just an American, but next Wednesday is Christmas for all of us and New Year's. Actually, that's not just an American holiday. I'm sorry. I've still got Thanksgiving on my mind. So I assume we're going to punt on the next two meetings, right?
Yeah, I think that makes sense. Yeah.
Yeah. So I will put those on the agenda here as we're going to skip the next two, and I guess we'll see everyone in 2025.
And I just made the last failing test work. So
Oh, awesome.
if
Ready to
any of the
go.
maintainers wants to check out the uh, Noble working group PR, it's all good now.
Excellent. All right. Well, thanks everybody for coming. We'll see you in a few weeks. Happy holidays. Oh, and here's Fabrizio at the very end.
Thanks, man.
See ya.
Later, everybody. Happy New Year and holidays.
You too.